Hello friends, I am Dilsukhnagar, maths lecturer from IIT Academy, so Dilsukhnagar. So today I will explain some previous questions. Previous questions is recently. So recently January 22, so 2025. Shift 1, shift 2, some few questions and from few topics. I will explain few questions. So this is the first question. So the coefficient of x to the power of 2012. So 2012 in this expansion. 1 minus x whole to the power of 2008 into 1 plus x square whole to the power of 2007. This is a recent question. January 22 shift 1 question from binomial theorem. So actually we want 1 minus x whole to the power of 2008 into 1 plus x square whole to the power of 2007. So here we want to find the coefficient of x to the power of 2012. Okay. So first of all, so just make the equate the powers. So first of all, 1 minus x into 1 minus x whole to the power of 2007 into 1 plus x square whole to the power of 2007. Now here, so these are okay, 1 minus x into, so this becomes, so powers are set, so just club the bases here, 1 minus x into 1 plus x square whole to the power of 2007. So this is in the form of a minus b into a square plus ab plus b square, that is equal to 1 minus x into a cube minus b cube whole to the power of 2007. Now here we want to find the coefficient of x to the power of 2012. So just write down the general term. Okay, so general term of 1 minus x cube whole to the power of 2007. So this question is completely based on, so general term pr plus 1 in x plus a whole power n, completely based on this question only. So therefore, so here already become the, so 1 minus x into, okay, 1 minus x into, so general term in x minus a whole power n, so minus 1, okay, minus 1 whole to the power of r, NCR, x to the power of n minus r, okay, x to the power of n minus r into a to the power of r. This is the general term. So now 1 minus x into minus 1 whole to the power of r, 2007 CR. 1 to the power of 2007 minus r, that is 1 only. Here we get x to the power of 3r. Okay, x to the power of 3r. So multiply this whole thing with 1. Again we get the same term, that is equal to minus 1 whole to the power of r, 2007 r CR, x to the power of 3r, minus, multiply this whole thing with x, will get minus 1 whole to the power of r, 2007 CR, x to the power of 3r is 1. So this is the thing. So we want to find the coefficient of x to the power of 2012 in this expansion. So I want to simplify this whole thing like this. Now we can find the coefficient of x to the power of 2012. Okay, we can find the easily. So just equate the x power, where x power is what? 3r. Equate 3r to, so 2012, because I want to find the coefficient of 2012. So r is equal to 2012 by 3. So 2012 by 3 is not divisible. So 2012 is not divisible by 3. So therefore, okay, so we will get the r value in terms of point values. So the point value does not exist because TR plus 1, the general term, R should be integers. Okay, R should be integers, natural numbers. So that's why this does not exist, because because 2012 is not a multiple of 3. So in the second case, this case, so equate 3r plus 1 equal to 2012, 3r equal to 2011, r equal to 2011 by 3. Okay, so this one also not a multiple of 2011. So 2011 is not divisible by 3. So this is also not a multiple of 3. So therefore both are does not exist. So therefore in this expansion, okay, therefore in this expansion the coefficient of x to the power of 2012 does not exist. Okay, does not exist. That is 0. Okay, so that does not exist. That is 0. Therefore the coefficient of x to the power of 2012 in this expansion is 0. This is our required answer. So first option is true. First option is true. So now second question from logarithms. From logarithm properties of logarithms. Suppose here what is given if e to the power of 5 log x whole square plus 3 is equal to x to the power of a, then product of all real values of x, okay, all real values of this numerical type question here. Suppose again 5, this is a given equation where e power 5 log x is the thing called log x base e whole square plus 3 equal to x to the power of a. Okay. Now here from this equation find the values of x, not all values of x. Here what? Product of all real values. Product of all real values of x. We want to find the product of all real values of x from the logarithmic equation. So this is general question. So general question from logarithmic properties. So now here set e, okay, set e on that side, then it becomes log. So 5 log x base e. 5 log x base e whole square plus 3 equal to log x base 8 base e, like this. Send e on that side, then we get the log, and then it becomes log here. So actually this is in the form of log a to the power of m, log a to the power of m, that is m log a, that equal to m log a. Clear? So 5 log x base e whole square plus 3 equal to 8 log x base e. So now this equation, this is a quadratic equation, log x base e whole square. So bring 8 log x base e on this side, so that v becomes minus 8 log x base e plus 3 equal to 0. Now convert this equation into the quadratic form. Okay, quadratic form. So assume that log x base e is equal to t. That is 5t square minus 8t plus 3 equal to 0. Now, so take the factors. The factors of this quadratic equation, so which is in terms of t. So 5t square minus 5t minus 3t plus 3 equal to 0. Now here take common. So 5 is common. Okay, 5 is common from the first two terms. 5 common, 5t common, 5t, t minus 1, minus 3 common, t minus 1. So t minus 1 common, 5t minus 3 equal to 0. So t is equal to 1, t equal to 1 or t equal to 3 by 5. These are the two t values, okay? But if we want to find the x value, but our assumption is, so what is t? That is log x base e. So log x base e equal to 1, log x base e equal to 3 by 5. Now here send logarithm on that side. So then this v becomes x is equal to e to the power of 1 or e. So from this x is equal to, okay, e power 3 by 5. Okay, e power 3 by 5. Both are rational roots x. But here we want to find the product of real roots of x. So the product should be, okay, so product of real roots equal to e to the power of n into e to the power of 3 by 5. So basis are same, power should be added. E to the power of 1 plus 3 by 5 that equal to e to the power of 8 by 5. This is our answer. So third question from functions. So sets and relation from function. So this is the question. If a is equal to 1, 2, 3, 4, one set is given. So second set b is 1, 4, 9, 16. 1, 4, 9, 16. If f maps a to b, if f maps a to b, then the number of many to one functions, many to one functions from a to b. Here we want to find the many to one function, number of many to one functions from a to b. Already two sets are given. A is one set, b is another set. So f is a one function between a and b. So we want to find the number of many to one function. Here already we know that suppose number of one function from a to b. So this is some set a, this is some set b. Total number of, okay, total number of functions. So total number of functions from a to b. Already we know the formula. N of b to the power of n of a. N of b to the power of n of a. So number of one functions. So formula for number of one function is a cardinal number n of a, cardinal number n of b. So number of, okay, number of one functions. Number of one function. What different elements will have the different images. Okay. So if a function which is not a one, that is many to one function. A function which is not a one means so all different elements. Okay. All will have the same one, not all. So number of one functions are formula for number of one function. N of b, p, n of a. This is the so number of one functions. Here we want to find the number of many to one function. Number of many to one functions means which is not a one. Okay, which is not a one. So therefore, here is the formula, simple formula. So number of, okay, number of many to one, okay, many to one functions is equal to first find the number of functions, then delete, okay, then delete the so one functions, okay, so number of one functions. So this is our required answer. N of b to the power of n of a. This is total number of function. From the total number of functions, so just remove the one function. We get the so many to one function. So therefore number of functions, we already know that a containing a is equal to 1, 2, 3, 4. This is a one set. B is equal to 1, 4, 9, 16. Cardinal number, already we know that n of a equal to 4. N of b equal to 4. Okay, n of a equal to 4. N of b equal to 4. So total number of functions. N of b to the power of n of a minus, okay, so n of b, n of a. So this is total number of function. This is a one function. Here we want to find the many to one function from total number of functions. So just remove the one function. 4 to the power of 4, that is 256 minus 4p4. 4p4 is 4 factorial by, okay, so 0 factorial, that is, so we get 256 minus 24. 256 minus 24, that is 232. So the number of many to one function from a to b is so 232. Our required option is second option is true. So next question from trigonometry. So trigonometric ratios. So this is a simple question. Sin 70 degrees into cot 10 cot 70 minus 1. Find the value of sin 70 degrees cot 10 cot 70 minus 1 value. So this is a very simple question. So completely based on the definitions for here. Sin 70, that is cot 10. cot 70 minus 1 is equal to. So now express this sin 70 degrees. Cot 10 is cos 10 by sin 10. Cot 70 cos 70 by sin 70 minus 1. Okay? This is the formula. We take the LCM. Sin 70, this is the LCM. So sin 10 into sin 70. Sin 10, sin 70 is the LCM. So then after the LCM, we simplify. So cos 10 degrees, cos 70 degrees minus sin 10 degrees, sin 70 degrees. So now sin 70. So this is in the form of cos 10 cos 70 minus sin 10 sin 70, cos A cos B minus sin A sin B, that is cos of A plus B, cos of 10 degrees plus 70 degrees by sin 10 degrees sin 70 degrees. Now here, so sin 70 degrees, so sin 70 degrees, this is cos 80 degrees. Cos 80 degrees by sin 10 degrees sin 70 degrees. So now sin 70 gets cancelled. Sin 70 cos 80 by sin 10. Cos 80 by sin 10. Now just convert the cos 80 in terms of 10 degrees. So complementary and complementary of 80 degrees. We can write cos of 90 minus 10 degrees by sin 10 degrees. This is the form of cos 90 minus theta. Cos 90 minus theta is sin theta. So that is sin 10 degrees. Sin 10 gets cancelled. Answer is 1. So therefore the required option is correct answer. This is fifth question. If mod of z by z plus I equal to 2 represent a circle with center P, then the distance of P from the D of 1, 5 is. Here we want to find the PD, that's it, PD. So D is given 1, 5, but P we don't know. So this is actually complex number question. So the complex number, this represents a circle. This represents a circle, but the circle is not in the general form. So first of all, convert the given equation into general form, then find the circle. So after getting the center, so that is P, then find the PD, that is a distance, okay? PD. Now, so assume that Z is equal to x plus iy. First step, x plus iy. Here just apply these formulas. Mod of z1 by z2, mod of z1 by z2 equal to mod z1 by mod z2. You can write separately mod z1 by z2, and already you know the modulus of, formula, modulus of x plus iy equal to under root of x square plus y square. Now convert so actually the given equation of circle is in complex form. So convert into general form, then find the circle after getting the center, then find the radius. So now, first apply the formula mod z by mod of z plus I is equal to 2. Now set this term on the side. Mod z equal to 2 into mod of z plus I. So mod z is equal to mod z, that is mod of x plus I by mod of x plus I by 2 into mod of x plus I by plus I. So this is in the form of x square plus y square 2. This is in the form of x square plus y plus 1 whole square under root. So now take I common. From this I common, x plus I of I plus 1, again that is in the form of mod x plus y. So that is in the form of under root. Now squaring on both sides. x square plus y square equal to 4 into x square plus y square plus 1. So this is simplified form. Now multiply here x square plus y square equal to 4x square plus 4y square 8y plus 4. 8y plus 4. So send all these terms from LHS to RHS. Then this becomes 3x square plus 3y square plus 8y plus 4 equal to 0. Now just make the coefficient of x square y square is 1. So take common and send 3 on that side. X square plus y square plus 8 by 3y plus 4 by 3 equal to 0. This is the equation of circular integral form. X square plus y square plus 2gx plus 2fy plus c equal to 0. Already we know that this is in the form of 2gx plus 2fy plus c equal to 0. Whose center is minus g comma minus f. Here g term is not there. So 2f is equal to 2f equal to 8 by 3, f equal to 4 by 3, f is equal to 4 by 3. So center already given, that is P. So 0 minus g comma minus f, g is 0. Okay, g is not there. G is 0, 0 comma minus 4 by 3. This is the center. So the center. Now after getting the center, now find the distance between PD. D is 1 comma 5. This is x1 y1. This is x2 y2. So now find the PD value under root of x2 minus x1 whole square. x2 minus x1 whole square plus y2 minus y1 whole square. 5 plus 4 by 3 whole square. That is equal to 1 plus, okay, 1 plus, so this is 15 plus 4, that is 19 whole square, 19 whole square by 9. Now take the LCM, 9 plus 19 square, that is 361 by 9, 19 square 361 by 9, so that will becomes root 370, here root 370, so root 370 by 3. Root 370 by 3. This is our required answer. Now, so the given equation is in the form of circle. So by using the circle complex form, find the equation of circle in general form. So substitute z equal to x plus I by the form by the mod. So after getting the center, now find the, okay. So center P D 1 comma 5. So just find out the PD, okay. So the PD, this is our required answer. Root 370 by 3. So the next question from trigonometry, inverse trigonometry. So that is related to inverse trigonometry. Alpha and beta are two real numbers. Alpha and beta are two real numbers such that secant square tan inverse alpha plus secant square cot inverse beta is equal to 36. So by using this equation, first equation, and second condition is alpha plus beta equal to 8. Second condition, then find the alpha square plus beta. Alpha square plus beta, already another condition is given if alpha greater than beta. Alpha greater than beta. Here three conditions are given. First one is secant square tan inverse alpha plus cosecant square cot inverse beta equal to 36. Second one is alpha plus beta equal to 8. Third one is alpha greater than beta. By using all these three conditions, so find the value of alpha square plus beta. Alpha square plus beta. So the first equation is secant square tan inverse alpha plus cosecant square cot inverse beta equal to 36. Here we can't simplify secant square and tan inverse alpha, cosecant square and cot inverse beta. So that's why, so just convert this. Okay. So already we know that formula secant square beta equal to 1 plus tan square beta. So secant square beta 1 plus tan square beta. This is beta plus cosecant square beta equal to 1 plus cot square. Okay, so 1 plus cot square beta equal to 36. So tan square beta is nothing but tan of beta whole square, tan beta whole square. Here also same, tan inverse alpha whole square, that is 1 plus alpha square 1 plus beta square equal to 36, and 1 plus 1 2 on that side. Alpha square plus beta square is equal to 34. This is first equation. And second equation is alpha plus beta equal to here. Second equation. So by using these two equations, find the alpha value. Right? We know that alpha square plus beta square equal to 34. Alpha plus beta equal to 8. So just convert into the quadratic equation in terms of either alpha or beta. So now from this equation, alpha equal to, we can write alpha equal to 8 minus beta. Alpha equal to 8 minus beta. Substitute this alpha in the equation number 1. Alpha value we get 8 minus beta whole square plus beta square equal to 34. 8 minus beta whole square. 8 minus beta whole square plus beta square equal to 34. This is in the form of a minus b whole square. A square plus b square. A square plus b square. So minus 2ab. Okay, minus 2ab, that is 16 beta plus beta square minus 34. Minus 34 equal to 0. 2 beta square minus 16 beta. Okay, so plus 30 equal to 0. Take 2 common, beta square minus 8 beta plus 15 equal to 0. Now take the factors here, 3 comma 5 of the factors. So beta equal to 3 comma 5. We get beta equal to 3 comma 5. Okay, so 3 comma 5 are factors. Then substitute beta equal to 3 comma 5 in alpha. Alpha is equal to alpha equal to 3 here, that is 5 comma 3. So these are the values. If alpha equal to 5, beta 3. And if alpha is equal to 5, then beta is 3. If alpha equal to 3, then beta is 5. These are the values. But here already given another condition, alpha is greater than beta. Alpha greater than beta, so just select this condition. Okay, don't take this. So by using this, find the value of alpha square plus beta. Alpha square plus beta is equal to alpha square, that is 25. 25 plus 3, that equal to 28. This is the right answer. So the second option is true.